Today, we will be presenting about how renewable energy can potentially reduce the increasing temperature in Singapore. A key reason for the escalating temperatures is the high greenhouse gas emission from the burning of fossil fuels to generate electricity. In Singapore, 95% of electricity is produced using natural gases. Methane in natural gases requires combustion, forming water and carbon dioxide. Carbon dioxide can accumulate and persist in the atmosphere for centuries, absorbing infrared radiation that was radiated by the Earth back into space, hence contributing to increased temperatures in the Lion City. Now, these renewable energy sources are the most efficient and feasible for Singapore. Firstly, solar power is a type of renewable energy that is generated using solar cells. Solar cells are made of semiconductors that partially conduct electricity. Solar cells contain N and P type layers. The N and P type layers are abundance of negative electrons and positive empty holes respectively. A P2N junction is formed when the N type layer is placed onto the P type layer. Due to a concentration difference of both electrons and holes on both sides of the P2N junction, some electrons from the N-type layer diffuse into the P-type layer, leaving empty holes in the N-type layer. Part of the P-type layer acquires a negative charge, and part of the N-type layer acquires a positive charge. The charge region is called the depletion zone. An electric field is created in the depletion zone by the charges. When photons from sunlight reach the depletion zone, it transfers its energy to an electron, pulling the electron out of its atom and leaving a hole. The electric field in the depletion zone drives the electron towards the N-type layer and the hole towards the P-type layer. When an electric circuit is connected, the electron in the N-type layer moves through the electrical circuit in order to meet the hole in the P-type layer, generating electrical current. Integrating solar power in Singapore is feasible. Singapore has advanced technology that allows solar panels to be built on top of buildings and the development of solar farms in Tengah. The sunlight that Singapore receives all year round into energy by solar panels is also feasible. However, integrating solar power in Singapore is not efficient. This is because solar panels cannot produce electricity at night as there is no sunlight. Some sunlight can be reflected off to the solar panels, and clouds can block some sunlight, especially during the northeast monsoon, causing less sunlight to be converted into energy. Furthermore, the average commercial solar panel only has an efficiency of 15 to 20%. Singapore might also have insufficient available land in order to build massive solar farms. Next, wind power is a type of renewable energy that is generated using turbines. Curved blades have air moving through the curved side faster than air under the flat side, creating a low pressure area on top. Less air resistance is present in the low pressure area, increasing the velocity of the blade. The speed of the wind turbine is increased in a gearbox which uses a planetary gear set arrangement. The shaft of the generator is spun by the turbine. In the generator, copper wire coils spinning past magnets generate electrical currents. Integrating wind power in Singapore is not feasible because there is little free space to build wind turbines in Singapore given their size, which can reach heights of over 100 meters, and Singapore has very limited land. Integrating wind power in Singapore is also not efficient. This is because Singapore's low average wind speed of about 2.5 meters per second is too slow for commercial wind turbines that operate at about 4.5 meters per second. High-rise buildings present in Singapore can also block or deflect winds. This ultimately causes less kinetic energy from the winds to be turned into less electricity by the generator. Hydroelectric power is a type of renewable energy that is generated using hydroelectric dams. Hydroelectric dams have large barriers that raise the water level. When water is released from the dam, gravitational energy of still water is converted to kinetic energy of moving water. The moving water turns the turbine, which powers the generator, producing electricity in the process. Integrating hydroelectric power in Singapore is not feasible, as Singapore's water bodies are flat and less than 50 meters above sea level. This mostly still water cannot turn the turbine to power the generator effectively, so little to no electricity is produced. Integrating hydroelectric power is also not efficient because hydroelectric dams can cost millions or even billions of dollars and many years to build, as shown in the diagrams below. This, combined with the production of negligible to no amount of electricity, hence makes hydroelectric dams not worth to build it. So, why choose renewable energy sources? This is because transitioning from renewable energy can decrease carbon dioxide emissions. As you can see from the graph, renewable energy sources like solar, wind, and hydroelectric power have less than 48 grams of carbon dioxide emissions per kilowatt hour of energy. In contrast, traditional energy sources like coal and natural gas that make up the majority of global energy sources produce 230 to 820 grams of carbon dioxide emissions per kilowatt hour of energy. Therefore, renewable energy produces less carbon dioxide emissions. So, how can we reduce the enhanced greenhouse effect? Less carbon dioxide emissions can reduce the effect of the greenhouse effect. Since the now smaller amount of carbon dioxide in the atmosphere will trap less heat, hence more heat will escape into space. With less heat being trapped in the atmosphere, temperatures on Earth will rise at a slower rate. Although rising temperatures cannot be mitigated, the rate at which temperatures rises can be slowed down. Thanks for watching.